Welcome to the fourth lecture in Module 1. In this lecture, we'll talk about design patterns. Now, we've already seen that modern web applications involve a significant amount of complexity, particularly on the server side. And a typical web application involves numerous protocols, programming languages, technologies that are spread throughout the entire web stack. Developing, maintaining, and extending a complex web application is very difficult. But if you have some design patterns in mind when you're doing this, it can help you significantly. Now, software engineers use abstraction to deal with this type of complexity, and design patterns are one way of creating useful abstractions for object-oriented systems that we'll use to help build these web application frameworks. So let's start with the definition of a design pattern. A design pattern is a description of interacting objects and classes that interact in order to solve a general problem within a particular context. So what does this mean? A design pattern is just an abstract template that can be applied over and over again to solve a generic problem. The idea is you apply the abstract design pattern in order to solve a very specific concrete design problem that occurs while you're trying to build a real system. Now, what does it mean when we say that it's solved within a context? The context is just the circumstances under which you're trying to solve a particular problem. The individual motivating factors, the actual problem you're trying to solve sets the context for the design. Now, design patterns are also very important because they provide a way for software engineers to communicate with one another. In other words, this is the vernacular that software engineers use when they want to talk about a design. Now, the whole point of a client-server architecture is to distribute the components between the client and the server in some intelligent way. This makes sense, for example, if you're trying to share a printer or share a database amongst users. You've got the users on the client side. You've got, for example, a printer or a number of printers that can be shared through this print server. So by distributing these things intelligently, it allows many people to use some number of printers. Now, what gets put where within this setup determines the type of client-server architecture that you're working with. And in order to build complex web applications, we're going to have to make use of numerous design patterns in order to figure out how to place things within this client-server architecture. The N-tier architecture is the first design pattern that we'll discuss. This design pattern is mapped on top of the client-server architecture that we've already discussed. This design pattern is based on this concept of breaking a system up into different pieces or tiers. This is where the name N-tier comes from. We're breaking it up into N different tiers that can be physically separated. So each tier in an N-tier architecture is responsible for providing a specific piece of functionality, and a tier should only interact with the tiers that are adjacent to it through a well-defined interface. The print server example that we already discussed is an example of a two-tier architecture. You've got the print server on the server side, and you've got a client who's interacting with it using, could be a browser, it could be through some other operating system, could be on the client side. Early web applications were two-tier client-server architectures. So they're a two-tier architecture. In this case, the user interface, the browser, was the client side, and the functionality that resided on the server side was delivering web pages. Not much more than that. Now, sometimes people refer to the client in this case as the thin client. There wasn't a lot happening on the browser in those days. The server provided static web pages, as we've already mentioned, and the interface between the two was HTTP. Now, additional tiers show up typically on the server side as you partition the server to provide more functionality. So what are the advantages of this design pattern? Well, the abstraction provides a means for managing the complexity of the design. If you're working with others on the design, you can focus on a particular tier and know that it just interacts with these other tiers through a well-defined interface. And so you can focus all your attention on that tier, knowing that you're not going to break something in another tier as long as you respect the interface that it uses. What are other advantages? Well, the tiers now, because of this design, can be easily upgraded or replaced independently as requirements or technology changes. Again, as long as the new tier uses the same interface as the old tier, you can pull the old one out, stick the new one in, and we see this all the time. We see web servers get updated, old one goes out, new one goes in, the application still works, the browser still is able to talk with the application through this web server. So this is an example of how you can upgrade a tier easily because of the design pattern being used. It also provides a balance between innovation and standardization. The things that are inside the tier, these are things that can be innovated upon as long as you stick with the standards that are defined at the interfaces. And so somebody can come up with a great new web server, a great new database. As long as the interface stays the same, you can have some innovation taking place. So this was a very important reason for the internet to be able to grow the way it did, is companies could innovate within those tiers. Tiered systems are also much easier to build, maintain, scale, and upgrade for all the reasons that we talked about. It's much easier to work on a tiered system if I can have a project team where one piece of that project team is working on one piece of the tier and a different group of engineers is working on a different tier. And as long as they can understand the interface between the two can work independently. So one of the most common design patterns is the three-tier architecture. So n equals 3 in this case. And we've got a presentation tier that is the user interface. We have an application tier that sits between the data tier and the presentation tier, pulling information from the data tier, operating on it, and providing it to the presentation tier. Now, in a modern web application that's deployed over the internet, the three-tier architecture, the presentation tier is the user's web browser. The application tier, we're going to spend a lot of time focusing on that. This is the web server and the logic that's associated with retrieving information from the data tier, which in our case, in many of the applications we're going to build, it's going to be a database. And so the application tier involves retrieving data from that database, operating on it, and providing it to the presentation tier. Now, the application tier is often subdivided into two additional tiers, a business logic tier and a data access tier. The business logic tier models the business objects that are associated with the application. So it could be, for example, in a vendor site, there could be accounts and inventories, and there are various business rules associated with those accounts and inventories that you have to define as a part of the business logic tier. And then the data access tier is responsible for accessing the database. So what's the advantage of breaking this application tier into two pieces? If we put a data access tier between the business logic and the database, it means that we can change the database. And we're going to see that in the Ruby on Rails applications that we're going to build. There's a data access tier that allows us to switch out the database and use a different database. So this is, again, some of the advantages that we've already discussed for three-tier or n-tier architectures. The presentation tier is also sometimes subdivided between the client tier, which we see again on the client side, and then a presentation logic tier that exists on the server side. The presentation logic tier prepares views or web pages that can be supplied to the client tier. Finally, the web server is often segmented out as its own tier as well. So we call this the web tier. Let's look at this now within the context of the web application architecture that we've already discussed. Here we see a client tier that maps to the web browser. We see a web tier that maps to the web server. And then we see this presentation logic, business logic, that this is the part that we'll spend a lot of time that maps to, basically this set of functionality here. And we'll spend a lot of time talking about the various design patterns that allow us to organize that intelligently. There's a data access tier that maps to these connectors I show here, and then a data tier that in most cases is going to be a database. So these are how these tiers map to the architecture. Notice, as I show in this figure, there's just a single interface between each of these tiers. And again, if you'd like to pull one of these tiers out and stick a new or upgraded one in there, as long as you respect the interface, you're able to do these things. So this completes the 4th lecture in Module 1.